I think that means you
That's
like
fine.
pictures of notes.
All good right there. See, it's recording the notes now. Hi. Hi. If you're watching this, sorry, I forgot to hit record the first 3, 7, 15 minutes. Okay, but the only thing, what did we say? This stuff is all the same as the other one, but slope is 0. Slope is something other than 0. Okay. They can pause it. All right. If our even scatter around the line y equals 0. Okay, so equals standard deviation, check residual plot for even scatter around the line y equals 0. And then let me explain what the heck those words mean, because those are some fancy words there. Okay, I'm going to take a ruler to this just to make it better. So what this means is if I draw a line here and draw a line here, that points are kind of all this far away. They're not super close on this side and super far on this side. They're all about the same, within the same distance away. So even scatter. You're not detecting some wild pattern. Okay, and then our last one. What's R? Random. Random sample or assignment.
Wait, you spelled it. If it's assignment, you don't do 10%.
Correct. And then it would just be lunar instead of liner. It should be lunar. Okay, there's nothing new there to what we did before break. I just wanted to go over them again because it's been like, I don't know, 11 days. And that means that you forgot everything. Okay, so do. Okay, this has a T statistic you have to find. So the confidence interval used T star and the test uses T. And here are the symbols. So this is little b minus big B. Okay, let's go over what those things are. Because I want to make sure that whole statistic minus parameter thing still makes sense here. Statistic minus parameter. Statistic means the sample slope from the printout data you have. And then this is your estimated slope, which you put up in your hypothesis. So that's always going to be 0. Can you follow me? So this is your sample slope minus predicted slope over standard error of the slope. Okay, now if you guys could, I don't know if you have the ability to have a different color or something. This number is going to come from data output. This number is going to come from data output. And this number is going to be 0 every time. Okay. Okay, unfortunately, you do need to pay attention to the low and high because the slope could be negative or positive. So if the slope, if the T is negative, you guys know what to do. Negative infinity to that. And if it's positive t, what do you do? True, positive infinity, yeah. Okay, now, other thing. What is the degrees of freedom for slope problems?
So n-2.
N-2. Great job. And it's n-2 because you have to subtract one from the x and one from the y because you have one thing you can't control in each. Okay, now there's an important note. Are you guys ready for your important note? Okay, do you understand what these words mean? If there is a p-value and the data output is always two-sided. Okay, what I'd like to do is pause real quick and show you what I mean on the team test. You guys are going to do the team test on Thursday. Here is your regression output for this first problem. But there are some numbers on here that we use and some numbers that we don't. Okay. Let's try to do this in a way that makes sense to you and is not memorization. Because memorization doesn't work long term, but making sense does. What kind of problem is this? What are we estimating? True, but what are we estimating? The slope. This problem is all about the slope. Got it? Okay, which one of these numbers up here is the slope? I love you. That's got the word constant next to it.
Is it the S?
This number is the slope, 0.0228.
Oh, you got that right.
Okay,
Bring it in, buddy.
okay, can you guys pause real quick? Okay, are we all okay? That number is the slope. Okay, this number is the y-intercept, put that, the constant, put the word constant next to it. This one is relating to the actual variable, which is apparently sigma x, which is awkward, but that's fine. Okay, are you with me? Are we doing a regression output for the y-intercept?
No.
No. We are doing a regression output for the slope. Okay, slope, right? So do you care what the standard coefficient of the y-intercept is? No. Do you care what the t-value of the y-intercept is? No. Do you care what the p-value of the y-intercept is? No. This whole problem is about the slope. You never use this, you never use this, and you never use this. This is the standard error of the slope. This is the t of the slope, which means they gave it to you in this. You don't even have to b minus b over standard error. They did it already. This is the p-value of the slope. They already did TPDF for you. You don't have to do it, but you do have to know that you want the bottom four numbers, because those all have to do with slope. And then we need the y-intercept for your constant. This guy, never used the other. Okay, good. Also, you're never gonna use the Oxford adjustment either. Just another note. Okay, what are these problems about? Slope. What numbers do we care about? The ones next to the slope. Okay. But however, this p-value here is for two-sided tests, meaning not equal to. So if the wording says greater than, what do I do? What do you do to get the two-sided? Times 2. So how do you undo times 2? Divide by 2. Okay, so we're gonna make ourselves a little note. I don't know what this particular problem is for, but this number right there that's given to you is assuming not equal to. If the problem is asking for less than or greater than, you have to divide it by 2. Yes, that is a not equal sign. Is it terrible or is it just squished? Okay, now back to this. Conclude. Mm-hmm. Hold on. Okay, now usually I state the ha here, and I did. I just stated it a little differently. What does the linear relationship mean? That the slope is not 0. Slope is something else. It's less than 0 or greater than 0 or just not 0. Something other than 0. Now I think I remember, if you guys think about the example we were working on, wasn't it terrible? The association was really bad. Anybody remember? Because the scatter plot was so awful. Okay, so we're gonna do the test for that now. Thank you for being chivalrous. Forgot when I got there.
Didn't say it's-
I knew there was, but I did, I just wanted to tell you. But in fact, something else. Anyway, okay. Last example, here we go. States. Null hypothesis. Alternative hypothesis. Beta equals. Alpha equals. Okay, null hypothesis. Beta equals 0 every time. Okay. Do the data provide convincing evidence of a linear relationship relating amount of fertilizer to yield per plant? Is it saying anything about a positive linear relationship? No. Is it saying anything about a negative linear relationship? No. So it could be either one. Do you guys see how you would tell? It would say positive or negative. Hello? Okay. Okay, so I'm going to direct you back to the graph so that you can see what Y is. It's yield per plant and X is fertilizer. Okay, do you guys all see where I got the Y and X from? The scatter plot? And we talked about they're going to have to give you kind of a large amount of stuff for you to be able to do these problems. Okay, and alpha is 0.05. Any questions about the state? Okay, plan. It says assume conditions are met, and then if you get that on a problem, you're the luckiest person in the world. Because that just took out basically the whole problem. But we're just going to put that the conditions are in the previous notes, just in case you're looking through this and you're like, how do you do the conditions? And then you could be like, oh, she says to flip to the previous note. Ah. Educational middle finger. Ah, yeah, that right there. The educational middle finger you're all giving me. Okay. Do. So I have T equals. Okay, now let's get our things. So notice, did I tell you guys that I printed this from CPM? Okay, what did CPM do that was smart? You know how CPM is, they're like crafty. What did CPM do?
Maybe both crowd.
True, yeah. Okay, if you remember in the word that they have to give you all the graphs, yes. But in the wording, it says that they spilled coffee on the output. Why did they do that? Yeah, so they actually spilled coffee on the two numbers that we need, so that you have to actually calculate them, because usually they're giving to you.
Very crowd.
CPS. Okay, so they're not hard to craft though, so B equals, what is little b in this output? Yep, 0.0173 minus 0. What is the standard error of the slope? Mm-hmm. The best calculations of all time. One 1.84. Okay, now I have a positive T. So what will my low and what will my high be? Low is 1.84. Yep. And here's a question. What's the degrees of freedom in this problem?
And minus two, but I don't know what else.
Yeah.
We're gonna have to research.
33 minus 2 is 31.
Mm-hmm.
Mhm.
0.0377. However, I got really excited. I thought I was going to be able to reject the whole, but alas. Right there. Yep.
Yeah.
Because that means when it's not equal to, it means that it means that it means that there it means that there's a chance it could be a negative slope and there's a chance it could be a positive slope. So you have to take into account both. Okay, conclude last thing. Not the last thing actually, but second to last thing. Probably a really good thing that we failed to reject anyway. You'll see why.
Okay, and then I wrote the convincing evidence, then I come up here and start copying off the question. Okay. So before we're done, we have one more thing to do. It says, state how your confidence interval from the previous lesson validates your conclusion. Okay, so we failed to reject. Now let's look at our notes from last Friday. Why does that make sense for our confidence interval we got? Because 0 is in the interval. Nice. Since 0 is in the interval, there's a possibility of no association. That's it. That's really it. That's everything. You know everything now. Oh, I do have a joke.